All right, so this is what we're going to break it down into. We are going to be able to graph the basic sine and cosine functions. We're going to talk about amplitude and period, okay, which deal with the sine and cosine curves, all right, which make more sense after we look at the general thing. And then we're going to sketch translations, right? Translations are, we look at the general equation and we have numbers multiplied, added, whatever, and then how does it shift the graph around? And we may look at a real life model too. But we're going to start with just the basic sine and cosine curve, and everything we do today is going to be based off of the standard or the basic sine and cosine curve. All right. So first, let's start with the sine. Okay. And all right, we're going to study techniques for sketching the graphs of the sine and cosine functions. The graph of the sine function is a sine curve. So you can sort of think about waves in an ocean. All right, that's kind of how the sine and cosine curves are going to work. They're going to look very similar, okay? But I'm going to copy this down real quick onto my -1, -1. So if you can sort of notice what's going on there. Use a different color. All right, so let me stop my share here. Have I started? I don't even know if I've started sharing my screen to you people at home. I haven't, so. All right, so let's look at this. Let me get these people off here. Okay. All right, so here's our basic sine of x curve. Okay. And let me turn the light on and maybe try to expand this out a little bit. All right. So now here's what we're dealing with when we're graphing it. All right. If I go back to my unit circle, which is a little bit hard to see on here, but what the points we're concerned about are our main points. 0, or 0 degrees, 90 degrees, or pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so our general sine curve, those are our key points. Okay. Now, based off my unit circle, that's very hard to see right here. Let me see if I can't make this easier to see. All right, so there's my unit circle. All right, I'm focused on the K point or the key points of 0 degrees, 90 degrees, 180 degrees, and 270. But everything we do on these graphing is going to be dealing with radians. So we're looking at 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, all the way around the circle. All right, and we're going to write them as ordered pairs. So the x coordinate is going to be the degree. Okay, so my x coordinate is going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, that's going to be my x coordinates. Now my y coordinates are going to be the value of the sine at each one of those. So on this unit circle, the value of sine is the y coordinate. So I'm going to write these down. At 0, the y coordinate is 0. At pi over 2, the x coordinate is 1. At pi, the y coordinate is 0 again. At 3 pi over 2, I'm at -1. And then 2 pi, we're back to 0. Okay? So I pull that off the unit circle. So now, if I'm looking at this, all right, sine of x curve, which this will not focus very good. Okay. All right, this is the standard sine curve for that range. And what we're generally going to be looking at today is we're going to be looking at the range from 0 degrees to 2 pi or radians, 0 radians to 2 pi radians, or 0 to 360. Now notice the x coordinate of my graph is in radians. That's radian measurements. Okay. Pi is just, so if I wanted to translate that back to regular numbers, pi is 3.14. So that point right there where pi is at about the x coordinate of 3.14. Okay. But if I use these points over here at 0 radians, the sine of x is 0. So I plot that point. That's where I get this first point, 0, 0. At pi over 2 radians, the sine of x, the sine of 90 degrees, or pi over 2, is 1. So that's where I get this point. The sine of 180 degrees, or pi, is 0. That's where I get this point. The sine of 270 degrees, or 3 pi over 2, is -1. That's where I get this point. And pi, yes. Oh. All right. Thanks, Randy. You 10 people at home, I guess, aren't paying any attention to know I wasn't muted. Y'all can start listening now. I don't see the chat. So we had 2 people now. Perfect. All right. So off the unit circle are key points. 0, pi over 2, pi, 3 pi over 2, 2 pi. Right? 90 degrees, 180 degrees, 270 degrees. So this is how we graph trig functions. All right. Now, right, each time we keep going around and around and around the unit circle, that just all repeats. So if I wanted to keep going, if I wanted to extend this graph, it's going to extend forever in this shape right here. It's going to keep going, going to go, okay? But today we're really just going to focus on this one section, basically one trip around the unit circle, okay? But that's where the points come from. All right, let me stop share here. And let me share screen here. right, so here's what they're talking about here. Now notice they extend left and right. They show you sort of they're faded out where it can go. Now, here's the things I want you to the big thing from here is what is a period. When they talk about a period, all right, a period is basically one cycle. All right, that period on the sine curve repeats itself over and over and over. The period is from 0 to 2 pi. All right, basically where it gets back to how long it takes it to get back before it starts repeating the pattern. Okay, so one cycle is period. So for a sine function, notice the period, the standard sine function, the period is 2 pi. It takes 360 degrees for the sine curve to sort of start repeating itself. All right, then every time I go 360 degrees around that unit circle, it just repeats. So extending it out, now we're, instead of a unit circle, we're looking at a coordinate axis where the x-axis is the radians. As I keep going to the right, it keeps repeating. As I keep going to the left, if I go the other direction, it keeps repeating. Okay? All right, now there's the cosine function. Okay? If we listed out the same thing as the sine, notice cosine at 0 radians, the x-coordinate of that is 1. So at 0, it's 0, 1 is the coordinate of the cosine. The cosine of 90 degrees, or pi over 2, is 0. The cosine of 180 degrees, or pi, is negative 1. The cosine of 270 degrees, or 3 pi over 2, is 0. And then the cosine of 2 pi, or 360 degrees, is back to 1. Okay? So notice, and let me plot this on this other one so we can see them overlapped, and maybe it overlaps on here. Here's a comparison of the two, I believe. All right, so there is a comparison of the two. All right. So the cosine, or the sine's on top, the cosine's on bottom. Notice the period is still 2 pi. For cosine, it starts up at 1, goes down to negative 1, and back up to 1 along the x-axis, the y-axis. All right, it takes 2 pi, or 360 degrees for it to cycle all the way through. Its period is still 2 pi. So the standard period for a sine and cosine function is 2 pi. Okay? Now we're going to look at some things later on that changes the period, which means it would go up and back to where it started quicker or slower. Okay? And notice we're looking, or the range goes from negative 1 to 1. Okay? That's what they're noting out there. Let me see if there was anything on this previous slide that we needed to see. The domain of the sine and cosine functions is a set of all real numbers, right? For the x, it goes on forever to the right, goes on forever to the left. But the range for the standard sine and cosine is negative 1 to 1. It goes down to negative 1, up to 1. That's as high and low as it goes on the graph. All right, and each function has a period of 2 pi. So that's what we've talked about so far. All right, so this is talking about what we just talked about. They went ahead and pulled off our unit circle. They looked at the major points there: 0, pi over 2, pi, 3 pi over 2, and 2 pi, and they listed the values for the sine of those radians and the cosine of those radians. Okay. So basically, to come up with the ordered pairs, let's see if this is going to write. Okay, so for the ordered pairs, all right, here's the x coordinate for all of them right here. And for sine, this is the y, and cosine, this is the y. So at 0, x is 0, y is 1 for sine, 0, 0 for sine, 0, 1 for cosine, pi over 2 for sine is pi over 2 comma 1, pi over 2 comma 0 for cosine, and so on. That's how we got those points to put the points on the graph. And I'm going to write those down so I have them real quick, because we're going to refer back to these points quite a bit. All right. In fact, if you have your unit circle, you might want to flip it onto the back and write this down, just because it may be helpful. Let me stop share. Let me share my whiteboard. I would write this down. Zero, zero, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and I've run out of room, 2 pi comma 0. I'm going to have to rewrite that because I don't have enough room. I got to write smaller. Sine of x, 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. And then the cosine of x is 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then at 2 pi it goes back to 1. All right, so you may want to write that down on the back of your unit circle, or have that written down somewhere. So because we're going to, a lot of what we do today is going to be based off of this right here, when we change the shape and the period and things of the curves. All right. Here's a note. It just asks us to notice that the sine curve is symmetric with respect to the origin. So if you split it down the y-axis and fold it over, it's going to match up on both sides. However, because the cosine is shifted over, it's symmetric with respect to the y-axis. Okay, so the sine curve is symmetric with respect to the origin. All right, whereas the cosine is symmetric with respect to the y-axis. All right, we'll see if that comes into play much. These properties of symmetry follow from the fact that the sine function is odd, whereas the cosine function is even. We talked about that kind of stuff earlier in the year. All right. So the cosine right there, as respect to the y-axis, if I folded it across the y-axis, it would line up directly with each other. Whereas the cosine, it would not. It's an odd function. It has origin symmetry. All right, but the domain and range, we just talked about that. Period x-intercepts where it crosses the x-axis is basically every pi units. So whatever you multiply by pi, that's going to be a point where it crosses the x-axis. For cosine, notice it crosses the x-axis at pi over 2. So at pi over 2 plus, and then every pi units from there, it crosses. It's odd, even, origin symmetry, axis symmetry. That's not really going to be much of what. All right, so now it's asking us to sketch the graph of g of x equals 2 sine of x. So this is what we're going to be talking about. This is basically what we're going to be doing today the rest of the time, is adding or multiplying or putting numbers within the standard equation, and how does that affect our graph as we do that. So we're going to sketch the graph of g of x equals 2 sine of x by hand on the interval of negative pi to 4 pi. All right. And really, we're just going to look at, right now, we're just going to look at the 0 to 2 pi, and then we'll expand it out. Okay. So we're looking at sine. Now notice, here's what it has. And let's, f of x equals 2 sine of x. All right. All right, here's how we're going to go about graphing that. I'm going to go to my move this. All right, so I want to graph 2 sine of x. So basically, my x values are going to stay 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so what I want are these 5 points, okay, as I put it in here. So if my radians is 0 and I plug in 0 for x, what is the sine of 0? Well, that's what right here. Sine of 0 is 0. Then I multiply that by 2, and I get 0. My next point, pi over 2. All right. Sine of pi over 2 is 1. 2 times 1 is 2. Sine of pi is 0. 0 times 2 is 0. 3 pi over 2. The sine of 3 pi over 2 is negative 1. 2 times negative 1 is negative 2. 2 pi, sine of 2 pi is 0. 2 times 0 is 0. So notice how multiplying the sine of x by 2 or by a number, basically, all I'm having to do is I'm going through and I'm taking the original y coordinates and multiplying them all by 2. And how does that affect our graph? Well, when I look at my graph, I've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right. And as I graph those points, okay, let's see if I can slide that down so we can see the whole thing. 0, 0 is here. Pi over 2, 2 is up here. Pi 0, 3 pi over 2 is down here. And 2 pi is here. And this is what it graphs like. It looks very similar to what we were already doing. Okay? But remember, our regular sine curve was this one. It went to 1. So basically, when we took and multiplied a number by out in front of that sine, okay, it basically doubled the height and doubled how high it went and doubled how low it went at each point off the 0. Okay, so if I had multiplied that, if I had put a 3 in front of the sine, then it would have gone up to 3 and down to negative 3. Now, if I had put a fraction, a number less than 1, 1/2, then it would have gone up to 1/2, down to -1/2. It would have flattened it out. Okay. So what we're recognizing is what happens when we multiply by a number out front. Let's see what they say on here. All right. So we divided the period 2 pi into 4 equal parts. All right. We haven't done anything to change the period. The period stayed the same. And then here's the graph of that. All right. Now, notice we only did from 0 to 2 pi. But if I keep going, if I want to go from -pi to 4 pi, then what do I have to do? I have to just keep adding, like going in the negative direction on the x-axis. I go negative pi over 2, and then pi. And then to continue on from 2 pi, then the next, you add a 1/2 a pi is 5 pi over 2. Add a 1/2 a pi would be, or you add 2 pi to it, you end up with 7 pi over 2. They didn't put what was right there. Notice they skipped off 2 pi, and that would have been what, 5 pi over 2, 6 pi over 2. But there they extended it out. But the key part, what we did was from 0 to 2 pi, which is 0 was here, and here's 2 pi. All right. Now, if I want to extend it out, like I said, to 4 pi, then I'm just going to keep going every, right? We're putting marks every pi over 2 or 1/2 pi. So 1/2 plus 1/2 is 1 pi. Pi plus 1/2 is 3 halves. 2 pi. 2 pi plus 1/2 is 5 halves. 5 halves plus 1/2 would be 6 pi over 2. 7 pi over 2. Then this would be 8 pi over 2 or 4 pi. That's where we would stop. But once we have the original from 0 to 2 pi, then I know it's just going to keep repeating. All right, so that's why we're focused on right now is getting from here to here, one period done. And then to extend it, we can just keep repeating what was going on. Okay. All right, let's see what they have next. All right, so now we're going to talk about what we just did is actually we just changed the amplitude, and we're going to look at what changes the period. Okay. All right, so now, as you saw, all we did was put a number 3 in front of the sine. It would work the same for cosine, which in this case is that a value. All right. Now we're going to look at what happens if we add a value. That d would be just adding a value to the sine. All right. The a value is just multiplying a number in front of the sine. And then notice we can also have inside of where the x is, we can multiply x by a number, or we can add and subtract. If you think back to the first of the year and we were transforming or translating lines, right? I think we said when you add a number to the x, it moved it left or right or up and down. I can't remember right now. If you added a number to an entire thing, it moved it one way. So this is what we're looking at here is we're going to want to know, how does this d, if I add a number to it, how does that affect the standard graph? We've already seen if I multiply by a number, that makes it go up higher and go down lower. But what about if we multiply a number by the x, or we subtract or add a number right here? How does that affect my graph? Does it shift it? Does it make it taller? Does it make it smaller? Does it scrunch it up? Does it flatten it out? What's that? Okay. And so notice the one we just looked at, the A right there acts as a scaling factor, a vertical stretch, or a vertical shrink. It stretches it up higher as it pushes it down lower. All right. When the absolute value of A is greater than 1, so if this number is greater than 1, right, just like we did a minute ago, it was a 2, so it stretched it up to 2 and negative 2. It's going to stretch it up. And when it's less than 1, like we talked about, if this were 1/2, it's going to shrink it down. It's going to like took the bottom and the top and pressed it together. All right. The high and low points are going to be smaller. And I think it's going to talk about amplitude. And that's what considered is the amplitude. All right. So a lot of your assignment is going to be on asking, like, what is the amplitude? What's the period? And things like that. The amplitude, all right. Now notice a standard sine curve, it goes down to -1, it goes up to +1. The absolute value of A is the amplitude. So this, basically this number right here, if you take the absolute value of it, is going to tell you how far it goes up and down. All right. So for a standard sine function, it goes up to 1, down to -1. That is an amplitude of 1. It's not from the very top to the bottom. All right. It is from the center of the graph to the top. So if you were thinking it waves, it would be from sea level up to the highest point of the wave is the amplitude. All right. And you find the amplitude simply by looking at the number that's been multiplied by the sine or the cosine. All right. And let's see, they should have an example here. All right. So here's 2 examples. Y equals 1/2 cosine of x. The amplitude of this one is 1/2. That means it's going to top out at 1/2. It's going to bottom out at -1/2. This one, the cosine of 3x, it's going to top out at 3. It's going to bottom out at -3. The amplitude is 3 for that one. All right. Now notice what they did. To draw it, we've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. So they took the corresponding y coordinates for the cosine and multiplied them all by 1/2. So we get 1/2, 0, -1/2, 0, and 1/2. And this is going to be exactly what we just did a minute ago with that sine curve. And for the 3 cosine of x, we multiplied those numbers by 3. And then this is what you get right there. The lighter gray, that's the standard cosine curve. All right. The one that's sort of shallow, right? That's got an amplitude of 1/2. So basically, anytime it comes off the x-axis, off of 0, it's half as high or low as it was from the original. And then the one that's going way up and down is this cosine function of 3 cosine of x. It's got an amplitude of 3. The amplitude is the distance from the middle of the graph to its highest point. Okay? It's not always the y coordinate because the graph could actually get shifted up. It's from the middle of the graph to its highest point, how many units that is. All right? So that's really not that difficult. All right. Now, notice, just like when we were talking about, if you're talking about like parabolas, if you make it negative, it flips the parabola upside down. Okay. So in this case, if I take the negative of the function, that is a reflection across the x-axis. All right. So -3 cosine of x, it's going to flip all those y values that are positive, it's going to flip them to negative. So basically, as you can see there, all right, the lighter or the darker one is the standard 3 cosine of x. Well, if I make it negative, then it just flips everything over. All the positives flip down to the negatives flip up to the positive. Okay? And remember, this is our standard from right here, 0 to pi is right here. That's the standard 1 period, 1 cycle through of it. Okay. All right. So amplitude's not too hard. All right, now we're going to look at what happens if we multiply a number by the radian. So say we have the sine of pi over 2. Well, what happens if we're multiplying that pi over 2 or that angle, that radian, by a constant? All right. How is this going to affect the change? All right. Because y equals a sine of x completes 1 cycle from 0 to 2 pi, it follows that y equals a sine of bx completes 1 cycle from 0 to 2 pi over b. So basically, if we take and we put a number in front of the x, okay, all right, that is going to change the period. The period is how long it takes to cycle back to go through 1 cycle. Standard sine and cosine, it takes 2 pi, 360 degrees. Okay? Now what this is saying is it's going to go from 1 cycle from 0 to 2 pi over b, or basically 2 pi over b is going to be what that period is, or the 2 pi over b is going to tell you how long it takes to 1 cycle. All right? So basically you take where it ends, 2 pi, and you divide it by that number in front of x, and that's going to tell you how long it takes to cycle. All right? So if I were looking at this, these two right here, how long is this going to take to cycle through? Well, this one, the period, is going to be what it was, 2 pi over b. So at 2/3 pi, okay, this is going to go through 1 complete cycle. It sort of compacts it. If I did it by 1/2, the period is going to be 2 pi over 1/2, which is 4 pi. So this would actually flatten it out. Okay, so if I have my standard graph, here's pi over 2, here's pi, here's 3 pi over 2, here's 2 pi. Okay, well, if I multiply that by 3 in front of that x, 2/3 pi is about right here. What's going to happen is that sine is going to cycle completely through in that amount of time. Okay? Now, if I multiply by 1/2 of x, that cosine, it goes from finishing its 1 cycle from up here back to here in 2 pi, and it's going to cycle to where it's going to do that period in 4 pi. So it would start up here at 1, and instead of going down through pi over 2, it's going to go down through pi. It's going to go back up through, and I might not even be stretching it out enough, because the standard goes down through here. Oh, actually, it's going to go down through 2 pi. I think 3 pi over 2. We'll look at it. I can't do it off the top of my head. But what it's going to do is it's going to cycle down and back up, and it'll get back to where it started, its repeat, at 4 pi. All right, let me see if they show us that so I can get an accurate. I don't know if they show a graph of that or not. Note that the period is greater than 2 pi represents a horizontal stretching. So if the B is, there we go. If the B is less than 1, it's a fraction like 1/2. It's going to stretch out that period. If B is greater than 1, it's going to shrink in that period. Okay. And that's because of the odd and even, but that's the way it works out. And we're going to look at how to do these and to come up with the ordered pairs here in a minute, and that'll get us a little straighter on it. All right, translations of sines and cosines. And actually, before we get into that, I want to work through this one. The cosine, let's do y. Let me draw this out. Pi over 2, pi, 3 pi over 2, 2 pi, and here's 4 pi. All right, here's what we're going to do. Let's go back to that previous one before we go on to translations so we can see. All right, so I'm going to take cosine of 1/2 of x, okay? And we said this is going to stretch it out, all right, because 2 pi over b or 2 pi over 1/2 is going to make that 4 pi, so our period takes 4 pi to complete. All right, here's 1, and here's -1. Now, let me make sure I'm coming up with my ordered pairs. One half pi over 4. Pi over 2. Yeah, okay, so what's happening here is if I'm going to list my ordered pairs, all right, for my cosine, half of x means I'm taking half of that radian. So half of 0 is still 0, which the y-coordinate is still 1. All right. Now, if I wanted to take half of pi over 2, that would be pi over 4, and I'm not using that on here. Pi over 4 is like whatever it is, but I want to go, what I'm going to do is I'm going to take my next point, pi, all right? If I take half of pi, that becomes pi over 2, and I'm sorry. If I take pi, all right, so if my x-coordinate is pi, 1/2 times pi is pi over 2, and at pi over 2, my y-coordinate is 0. So notice how this is working. All right, let's use 2 pi. All right, when x is 2 pi, half of x would be pi. The value at pi is -1. All right. Now notice what we're trying to do is when we're finding the sine cosine, we're wanting to strictly stick with this. It's either 0, 1, or -1. Okay. Either we're looking to find the sine cosine of 0, 90, 180, 270. So that's why I'm skipping over some of these, because as I go here, 0, 1, pi 0, 2 pi negative 1. Notice it's made half its rotation right there. The next one I'm going to go is 3 pi, which would be what? Well, let's just put in 4 pi. What's going to happen when I go to 4 pi? Well, half of 4 pi is 2 pi, which the cosine of that is 1. So I know it's going to be back up here at 1. So if you'll notice, it's going to go there. And let's see, we said that was 4 pi over 2, 5 pi over 2. This is 3 pi right here. 3 pi, if I did 3 pi, half of 3 pi is 3 pi over 2, which we know is 0. Okay, and we'll go over that some more to make it a little bit more. But I just wanted to let you see why it stretches it out. All right. Let's go back to this now. Translations. And hopefully we can get this all a little bit clearer once we get towards the end here. Just got through the basics. All right, sine and cosine functions can be used to model many real life. That's not where I wanted to go with that. Let's see. All right, I'm going to have to pull something out of the book because we're not quite ready to. They skipped a lot in this PowerPoint. All right. What happened? All right, let me go back. Oh, there went Zoom. That did this yesterday too. All right, you people at home, I don't know what happened. My Zoom just cut off, so we're going to circle back to this this period. When we talk about translations. All right. Where is one? Where is? Let's just do this right now. Say we have y. And I'll tell you what we may do is, let's do this. Let me pull up what will be our assignment and start looking at some of this, because there's There's not a lot of graphing with it. All right, so here's what I'm going to do is I'm going to go to the WebAssign assignment that I will assign. And of course, it's not opening. And let me, my assignments, 4, 5. All right, I'm going to share my screen here. Preview the assignment. Okay, so this is going to be, to me, the easiest way to sort of work through some of this is just sort of go through the assignment, make sure we've covered everything we need to cover that you can get. So if you'll notice that the first one is the period. We talked about period of sine and cosine is 2 pi. It takes 2 pi to go through one cycle or period. All right. How do you find the period of the cosine? So we said the period is going to be the period is just 2 pi over whatever the b value is. That's going to be the period. Okay, that's how long it's going to take to cycle through. Okay. Amplitude. We said amplitude equals the absolute value of the a value. So in that case, the amplitude of y equals 4 sine of x. The amplitude is the number out in front of the sine or the cosine. So in this case, the amplitude is 4. Okay. The next one here. Use the graph to answer the following. Notice they've graphed it from negative 2 pi to 2 pi. Find the x-intercepts. So the x-intercepts are just as where it crosses the x-axis. We're going up by half a pi. Pi over 2, pi, 3 pi over 2. This would be, what, negative pi over 2, negative pi, negative 3 pi over 2. The y-intercepts, this was just 1. It crosses right there at positive 1. Intervals in which it's increasing. So increasing from here to here and here to here. There's 2 intervals that it's increasing. From what, negative pi to 0 and pi to 2 pi. Decreasing from negative 2 pi to pi, 0, 2 pi, that's a negative pi. Negative 2 pi to negative pi. The relative maxima we talked about before is the high point. All right. And your answers is comma separated, so it wants to know negative 2 pi, 0, and 2 pi. The relative minima are at negative pi and pi. I think we can handle that. All right, find the period and amplitude. So if it's asking us to find the period, they want to know where it starts at 0, how long does it take it to cycle back to that part before it repeats? And if you'll notice on this one, now they numbered this 1, 2, 3. So it starts here, goes down, and then it starts repeating again right there, which is at about 1.5 or 1.5 is what it looks like. It looks like it's got it divided into 5. So 2/10, 4/10, 5/10. It looks like it is 1.5. The amplitude is how far is it from 0 to the top? That's 3 units. Period and amplitude. So here we can easily see the amplitude is 8. Remember, it's the absolute value of the number in front of the sign. For the period, we would take 2 pi over 1/5, right? That's 1x, 1/5 x, x over 5. The period is 2 pi over b. So it would be 2 pi over 1/5, which ends up being 10 pi. So same thing there. We just use those two. Period and amplitude, we use those two. We're comparing F and G, the light colored one with the blue colored one. All right. The period of G is 4 times the period of F. Let's see, the period of F is 2 pi. The period of G goes here is half a pi. So what's half a pi times 4? Yep, that would work. Amplitude is 1/4. You compare the amplitudes are the same. So that wouldn't go. We haven't talked about phase shift yet. So let's see. All right, it looks like the rest of it's going to be dealing with shifts. So right now, and we're fixing to go and we're going to have to split this up. I'm going to have to go over the rest of it on next class period. So here's the biggest thing. Let me try this down to what we need to make sure we know right now off of this. Is if we have, right now, we have y equals 3 sine of x over 3. All right. From that, we need to know how to find the amplitude, which the amplitude is this number, the absolute value of that number in front of the sine or cosine. So we should be able to answer that amplitude is 3. We also need to be able to answer what is the period. How long does it take to go through one cycle? Well, that is always 2 pi over the b value. In this case, the b value is 1/3, right? The pi has an understood 1 in front of it, 1/3 pi. So that would be 2 pi over 1/3, which would be 2 pi times 3 over 1, which is 6 pi. So you need to be able to find the amplitude and the period based off the graph. You also need to be able to look at a graph and tell me what the period and amplitude is. So if I have a graph, and this graph is a sine, and it goes like this. Let's see. This is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. I need to be able to look, and I want to know what's the period here. Well, notice it starts here. The sine does. It starts here, and then it starts repeating right there, which it did one cycle in pi, so its period would be pi. Its amplitude, based off the graph, is from the center of it to the top. That's 1 unit, so its amplitude is 1. All right. So with what we've covered so far, and then Monday I'm going to go back over some more on how to actually put these graphs on here based on this stuff. Okay. And then we're going to talk about shifts also. But that's the biggest thing. We need to make sure we have y equals 4 cosine of 3 pi. Right? Amplitude's 4. Period is 2 pi divided by 3. Be able to pick out a period on a graph. Be able to tell the amplitude on the graph. All right. And then we're going to get more into using these up here to come up with our actual points and graphs next time. All right. I didn't explain that very well today, so I'm going to go back through that. I won't add an assignment yet because we haven't covered all this yet. Sort of a long lesson, but I'm going to shut it down now. Got about 15 minutes for lunch, and then after lunch, you can use it like a study hall to finish anything you need to finish if you haven't finished anything in here or whatever. And then we'll be back in here Tuesday, and we'll finish this assignment and get 4.5 assigned. Okay. So let me stop the share. And let's see, I need to stop the video.